In this video discussion, we're going to talk about OpenStack's object storage. Object storage in OpenStack is designed to provide a way to store large amounts of objects, each of these objects being fairly static and being able to be identified by a unique URL. The OpenStack object storage is codenamed Swift, and so you'll hear it frequently referred to by that codename of Swift, and it's a multi-tenant object storage system. So it's not file storage and it's not a volume, it's objects that we want to refer to as individual things. Now, how you define those objects, that's up to you and your application. But as far as the storage is concerned, it's going to be an object with metadata and a URL to access it. It holds vastly large amounts of static data, and both in terms of the size of the objects and the number of objects, it can handle a large amount of data. It's horizontally scalable. It can go across, as with the rest of OpenStack, to thousands and thousands of nodes. It's based on the idea of using commodity hardware. Instead of expensive RAID arrays, basically using commodity hard drives and relying on a replication process to ensure that copies of the objects are kept highly available. Nodes can be added anytime. Storage can grow in a very elastic, cloud-based kind of way without a lot of hassle, without a lot of difficulty in expanding either by nodes or by storage connected to the nodes. It uses a RESTful API over HTTP to access each object or the metadata about each object. Each object has a URL that can be used to uniquely reference that object, and each object has associated metadata. Now, for example, the owner of the object can set an expiry time after which the object is no longer available or is even purged. So there's a number of components that all work together to make this happen, and you should be aware of what some of them do. Proxy servers are a tool that when you interact with the data stored in Swift, you actually talk to a proxy server so that you can determine, or your application can determine, where the actual object is currently existing and return it. Accounts are a list of containers, and containers are a list of objects. Now that probably sounds a little more complicated than it needs to be, but each account and each container is an individual SQL-based or SQLite-based database, and the database itself is distributed across the cluster. An account database simply contains a list of containers in that account, and a container database contains a list of the objects in that container. And then to keep track of those locations, each account in the system has a database that references all of its containers, and those containers reference each object so that they can be found when they're needed. Partitions are used in the replication process, and they're simply a grouping of all the other objects, including account databases, container databases, and the objects themselves. The OpenStack documentation refers to it as, imagine a bin making its way through the warehouse, and as various objects are used to fulfill an order, they're tossed into a bin. But everybody just deals with the bin. They pick up the bin and carry it around when they need to. And so partitions work a little bit that way. It's a lot easier to work with a partition representing a whole group of objects than a whole bunch of little tiny objects. So when the system detects that a partition needs to be replicated, it can replicate the entire partition. Rings are used to map between partitions and the actual storage node. So a ring is a mapping. It's a mapping between the names of entities stored on the disk and their physical location. There's actually a separate ring for accounts, for containers, for objects, and when any other component needs to perform an operation on an object, a container, or an account, they interact with the ring through the proxy server to determine the actual location in the cluster of storage. And Swift supports the idea of zones. This isolates failures. So each data replica resides in a separate zone. So Swift keeps 3 replicas of all the objects, and they're all in different zones. So at the smallest level, a zone could just be one drive or perhaps a few drives, or it could be a rack, or it could be a data center, or it could even be a geographic area. The goal of zones is to allow the cluster to tolerate significant outages, where we lose a significant amount of access, either by hardware failure or network failure, and still serve all the requests for those objects from another zone, thus leading to the highly resilient, highly available object storage designed into OpenStack.